Imagine stumbling upon evidence that a far-off rocky world might be cloaked in an invisible shield, fending off the brutal onslaught of its star. Could this be the game-changer in our quest for extraterrestrial life? Scientists have just unveiled a thrilling discovery: recurring pulses of radio waves emanating from a nearby red dwarf star, synchronized with the orbit of a petite planet called YZ Ceti b, only 12 light-years from us. This rhythmic pattern strongly suggests the presence of a magnetic field enveloping this exoplanet, a feature astronomers have dreamed of detecting outside our solar system. But here's where it gets controversial. Does this truly prove a protective barrier, or could it be something else entirely? Let's dive deeper into what this means for our understanding of distant worlds. Researchers from the University of Colorado are excited because this detection hints at an interaction between YZ Ceti b and its host star that only a magnetic shield could explain. For beginners, think of a magnetic field as a giant, invisible bubble that wraps around a planet, much like Earth's magnetosphere, a protective force field that deflects harmful solar winds and charged particles, preventing them from stripping away the atmosphere. Without it, a planet's air could gradually erode, leaving it barren, as we've seen on Mars. Yet, the reality is more nuanced. Computer models reveal that even planets with magnetic fields can lose atmosphere if the solar wind is fierce enough. It's not a simple on-off switch. Factors like the planet's gravity, atmospheric composition, and the star's intensity all play crucial roles. And this is the part most people miss. For exoplanets orbiting other stars, pinpointing the strength of these fields has been a glaring gap in our knowledge, complicating the puzzle of why some worlds retain habitable conditions while others don't. Zooming in on the system, YZ Ceti is a red dwarf, a diminutive, cooler star with roughly 1/8 the mass of our Sun and a much fainter light. These stars burn through their fuel at a leisurely pace, potentially shining for trillions of years, but they come with a fiery temper, erupting in frequent flares that bombard nearby planets with radiation. Astronomers have spotted at least 3 small worlds encircling YZ Ceti, all huddled closer to the star than Mercury is to the Sun. YZ Ceti b, the closest of the bunch, steals the spotlight here. Through tiny wobbles in the star's movement, we've inferred it's a rocky planet weighing about 70% of Earth's mass, whipping around its star in a mere 2 days at a distance of roughly 0.016 astronomical units, extremely tight by cosmic standards. To hunt for magnetism, the team deployed the Karl G Jansky Very Large Array, a sprawling network of 27 antennas across New Mexico's desert, observing over 5 sessions. They captured brief, intense bursts of polarized radio waves in the 2 to 4 GHz range, with 2 aligning perfectly to YZ Ceti b's orbit. The initial bursts stood out vividly against the background noise, sparking intrigue. Experts interpret these as signs of star-planet interaction, charged plasma from the star colliding with the planet's magnetic field, releasing energy that produces radio emissions and even auroras on the star. This offers a glimpse into extrasolar space weather, those raging storms of radiation and particles that could reshape planetary atmospheres. Understanding this volatile environment is vital, as energetic outbursts from active red dwarfs can strip away air or alter chemistry on orbiting worlds. But here's a controversial twist. While these bursts point to YZ Ceti b potentially having a magnetic field, the case isn't airtight. Similar signals might originate from the star itself, and more observations are essential to distinguish between the two. Some theories propose the planet orbits in a subalphenic zone, where the star's wind lags behind magnetic waves, potentially fueling radio signals through magnetic reconnection, a process where opposing fields snap together and release energy. Despite any magnetic armor, YZ Ceti b faces an unforgiving existence. Its close-in orbit subjects it to searing radiation, making its surface scorching hot and likely uninhabitable, even though it's Earth-sized. The true excitement lies in extending this radio detection method to milder worlds farther out, where liquid water and temperate climates could thrive. By correlating radio bursts with planets in these Goldilocks zones, scientists could identify which ones boast sufficient shields against stellar fury. For the first time, we are directly probing the magnetic defenses of rocky exoplanets rather than speculating. This transforms magnetic fields from mere curiosities into key players in deciphering atmospheric survival and resilience against cosmic tempests. As advanced telescopes and arrays become available, astronomers aim to survey more nearby stars, compiling a database of worlds with detectable fields. YZ Ceti b might just be the pioneer in revealing the hidden magnetic guardianship of rocky planets via radio surveys. The research appears in the journal Nature, marking a pivotal step forward. Enjoyed this cosmic revelation? Sign up for our newsletter for more captivating stories, insider exclusives, and the freshest updates from the universe. Don't forget to explore EarthSnap, our complimentary app crafted by Eric Rawls and Earth.com. What are your thoughts on this breakthrough? Do you believe magnetic fields are the ultimate decider for habitable exoplanets? Or should we consider other elements like tidal forces or planetary composition? Is there a chance this could lead to false hopes in the search for life? Or does it open doors we never imagined? Weigh in below. Your opinions could spark a lively debate.